All right, here we are in the polar coordinate system now. So here we have a polar coordinate plane, and it's superimposed on top of the XY plane. So this could be the x-axis and the y-axis. It's right on top of it. And we can see the connection between those points in the polar plane with points in the rectangular plane using these conversion equations. Okay, we can see those connections. Now, if you just pick a point out here, sort of random point, you can see how our relationships exist. This could be r theta, and if it's theta there, then this could be x, and this is y. So that corresponds to the xy, okay, in the xy plane. And we see the connections here between these two. This is r. Now r is a directed distance, which means it could be positive or negative. Okay, so unlike with trigonometry, we don't see that in a negative r, but in polar coordinates, we will see a value of r that could be negative. So here's a point out here. Comes out r theta measured off of the polar axis here. Okay, so theta is measured off of the polar axis, just like we would do it for a unit circle, same sort of thing. Now, and theta is a directed angle also. It could be negative, but I've drawn one here in the first quadrant, and it's a positive angle, and r is positive also, the way I've drawn it. Now, you can see from this relationship here that cosine of theta is x over r. So there's our connection, that x is r cosine theta. And that's our first one here. And we have a similar relationship for the y. Y is r sine theta, and also tangent. Another one we have is the relationship Pythagorean between x, y, and r. Okay, so now let's look at a problem here. Convert this point to rectangular coordinates. Okay, well, if you want, you could find it first. Okay, so here's the polar axis. This is the pole. Now, I always draw this line in here. It's more or less, it's a ray. It's the ray theta equals pi over 2. But it's out of habit. I always draw it in as my y-axis, but it's basically in the same place. Now, so I'm at pi over 2, which comes out this way, pi over 2. And I have 8 units positive. That means coming upward out this way towards along the ray. Okay, in the same direction as the ray. I come out 8 units. So this is 8 pi over 2. Okay. Now, we can see pretty readily, because I have it in the drawing here, that my x is a 0 and the y is equal to an 8. That's pretty evident from here. But if you wanted to, you could use our conversion coordinates. Relationships here. X is r cosine pi over 2, so it's 8, which is a 0, and y equals 8 sine pi over 2, which is 8. So those are our coordinates, 0, 8, which we can easily see from the drawing also. Okay. So let's see. There's another one here. Okay, here's a question. Let's bring it back over here. Okay. Okay, so here's another question. Let me blow this up a little bit. Okay. Find 2 different polar forms for this point where theta is between 0 and 2 pi. Okay, so 2 different forms. That's the other thing about polar coordinates. That is that you can have multiple representations in polar coordinates for the same point. So let's take a look at that over here. Here's my polar axis, and here is theta equals pi over 2. Okay, so this point 2, 2, they're telling us it's rectangular, so this is x and y. So x equals r cosine theta, and y equals r sine theta. And we know r squared equals x squared plus y squared. So we can see right away that r is going to be square root of 4 plus 4, which is 8. And you can write that as 2 root 2. Okay, now we've got r, we need theta. Well, theta is the arctangent y over x, which in this case is 2, arctangent 2 over 2, which is a 1, so it's pi over 4. So there's one angle that's pi over 4, and that one fits. So that's our first one here. Here's our point. Okay, there's r theta. Now, that's one of them, and it fits because pi over 4 is between 0 and 2 pi. But the other one, of course, we could spin all the way around to get a coterminal angle with the same r, but adding 2 pi to this number, pi over 2, so it would be, 9 pi over 4. That'd be another point there. But that's not the one that they wanted. Okay, let's go only halfway along that ray, but then go backwards here. In other words, I'm going to go out 1, 2, 3, 4, 5. I want 5 pi over 4. But then I want to go backwards, negative 2 root 2. So I come out this way, but instead of heading out along the direction of that ray, I go backwards, opposite of that ray, and I end up back over here. That's the 2 root 2 distance. Okay, so this is another ordered pair for that same point. And you can see how you could do this infinite number of different ways to label that same point. Without this restriction, there could be many, many more. But even with this restriction, I found 2. I've got this one and this one. Okay. So in the future, there may be ways to restrict this so that there's only one point that represents a given point. Okay, let's continue. Okay, get that over there. All right, so we're back here now. We're going to do a little graphing. Now, we know what this graph is here. we've seen it already in several places. We know that that's a hyperbola, right? So we kind of know what to expect, but it says sketch this graph and then convert to polar form. So I don't have to use this same grid here, but it's here, so I guess we could. Let's look at this. X squared over 9 minus y squared over 9 equals 1. So kind of have a square hyperbola here. The major is along the x. We have center at 0, 0. We've got a equals 3 and b equals 3. So let me see. Let's say that these are 2 apiece. So we'll come out 3 in this direction and 3 in this direction. Okay, and we're drawing those up. Those asymptotes. And so on the x, so I know it's going to come up like this, down like this, and likewise in here, and out this way. Okay, so a little bit sloppy, but that's my graph. Let's see what else now. Okay, so it says then convert to polar form. So let's take this now and use our relationships. We know that x equals r cosine theta, y equals r sine theta, and x squared plus y squared equals r squared. So we can play around with this a little bit. Let's see what we get here. I could write this in as r squared cosine squared theta minus an r squared sine squared theta is 9. And then I notice the r squared comes out, cosine squared theta minus sine squared theta. So, I mean, technically this is the equation, but we can clean it up a little bit. I mean, it is in polar form because notice we have r and we have theta, no more x's or y's. But we might also clean this up a bit. Cosine squared minus sine squared is cosine of 2 theta. So we can even write this 9 cosecant 2 theta like that, just by multiplying. And this would be good enough. I hate to go into the radical form plus or minus 3 square root, but I mean, it isn't going to change. You've got the same function, but it's 2 pieces here now. Okay, now let's hold that thought, and I'm going to pull out the calculator. So just, okay, a couple things here. First of all, I just realized I got a little problem here. This just should be a secant here. Let's fix that. So you've got a secant 2 theta. This is a secant 2 theta. Okay. Now on the calculator, so come in, and I didn't show you this before, but this does have a polar mode in case you don't know. You can find it under the mode key and head over. Remember, we had parametrics. Now we got polar, so you got to come over and highlight that. Come down and select it if it's not already. Okay. So then you have a window to worry about. I'm going from 0 to 2 pi to see what happens. I'm not sure what's going to come out of this. We'll see when it graphs, but here's what happens when you go to graph it. I'm going to put this in 3. Okay, let's see what happens here. Now I'm seeing part of it. It's sort of jumping around, giving me pieces. and I don't have the whole picture. So I probably would have to change my window, put in a little bit bigger theta max, or I could use negative values of theta. I might actually put in, let's say, let's go negative pi. Let's see if that gives me enough. And then graph that. All right, so still not quite enough to get the whole graph. I'll make this 2 pi here. So 2 pi. Whoops. I gotta get rid of that. Okay. And I'll enter that and I'll graph that. Okay, so I'm still missing a little bit here. Let's try that again. Make sure that's all good. Okay, I got the 3, and notice I'm getting most of it, even without that negative 3 that's down in here. Okay, I'm getting most of it without that. If I change that window a little bit more, maybe I'll make this, let's do 4 pi. And then let's make this 0. Let's see if we can get away without that. Okay, and graph it. Okay, so that actually gave me the same thing. Looks like I need a little bit more. What if I made this? I made it 4 pi. Let's make it 6 pi. See what happens there. Okay, so I'm not, it's funny, it's giving me most of it, but not everything. Let's see if I made that a little bigger. I had 6 pi, let's do 8 pi. Doesn't seem to want to go past that one spot there. I picked it up. There it is. All right, so I almost got it. Now my guess is that we could probably put in that negative, and so that was 8 pi. What if I made this 10 pi? I'm thinking I'd get it all with that. Okay, so it finally did give me everything I wanted. Um, so we have to be careful with how we graph with the polar coordinates here, because you may not even see the whole graph if you don't get the right window, if you don't put in the right values of theta. So that's what happened here. And I guess I might have been able to do half and half and see most of it if I had gone from maybe, say I used 10, so maybe I'll make this minus, whoops, if I did 5 pi and made this 5 pi. Wasn't enough to pick up that last one. So different windows you have to play with to make sure you get the full graph. It's not predictable what's going to happen. So now, short of building a whole chart, this, the calculator is the way to go on most of these. There are some specialized polar graphs that show up often enough and are useful for testing some of our theories and doing practice problems with some of the applications. They show up more often, and we'll see a few of those in this next in the next few places here. All right, here's another one. We're going to approach this the same way. Let's convert this rectangular equation to polar form and sketch the graph. Now, obviously, x equals 12 is easy to graph. You don't need polar coordinates to do that. We know what this is going to look like. But so we know it's a line out at 12. So you're going to have something. Let's say this is 3, 6, 9, 12. So we're going to have a line like that, vertical line out there. That's a horrible line. Let's try it again. Out here at 3, 6, 9, 12. Looks like that. Okay, now I did a little bit of work on this one, just in a few seconds there, we were missing. Okay, here's my equation converted. And to build it by hand, you'd have to do this. And I stayed in the first quadrant here, and I've got numbers increasing here all the way up. And if I plotted them accurately, I would start to see a line, assuming I had that much accuracy available. But we can also see this happening on the graph. If we come in here, let's see what we have here. Okay, let's see, we want 12. We have to divide that by the cosine of theta. Okay, and let's see what that looks like. Uh-oh, something wrong there. Like an extra parenthesis. Okay, so like that. Come on in, see what this looks like. Okay, now what's happening is I don't see a picture because my window is too small. Okay, let's come in here. I'll make this, first of all, I only need, well, I could use some negative numbers, but let's just start with 0. See what happens here, and then I have to make this big enough to see it, so I'll start this at 0, make this about 15, and let's see if we can get some. We'll make this 20. See what that looks like. Okay, and there it is. There's a straight line, and it's giving me 2 pieces down, negative and positive. Now you can do some tracing here. We have, let's see, now this is tracing, let's say 0 for theta. So we get x and y. They're not giving us r on this trace, just theta. Okay, it'd be nice to be able to see the r value, but I can't see that here. If we go to the table, you might see it. Okay, there's our values for theta, for R1. Theta is, well, these aren't the numbers that we're using, but let's see if we can put in, let's put in our pi over 6. Let's see if we can confirm that. See what happens here. pi divided by 6. Okay, so it's not actually allowing me to do that. Let me see if I can come in here and do the table set. Okay, that's what's wrong. I'll do the ask on that, and then back to the table, and I'll put in a 0 as my first value, and I'll put in pi over 6. So we got to, just work with it. There's my 13.9, and then let's do pi over 3. That's a nice one. And there's the 24 for the R value. And you can get close to pi over 2 without getting there. For instance, you could take pi over 2. Let's make it a little bit less than half. So we'll say 0.49 pi. Let's see what that gives us. Okay, pretty big number. You see, just heading out along that line out to eventually R will go out to infinity. But okay, so that's pretty much how we would approach a graph. Kind of going into the unknown with these graphs, you have to be careful with thetas and make sure you're seeing what you think you're seeing when you're doing the graphs. Now, I didn't do any negative values here. I think in order to get this negative portion here, I would assume I'd have to get some negatives involved with theta to drag it down. If you went past the pi over 2 and started going into negative numbers, let's say pi over 2, it doesn't exist. I think you start to pick up your negatives. They'd be quite large, small actually. So let's just try that. Back on the calculator. Let's get a couple negatives in there. Let's try negative pi over 4. Let's try that. Okay, let's see what we get there. Okay, so I'm still getting positive. All right, I'm going to continue past that. I'm going to do 3 pi over 4. That's what I meant to say. I meant to do the 3 pi over 4. Let's try that. 3, whoops. That's 3 pi divided by 4. That puts me in the second quadrant. Okay, so there's my negative. Okay, so I do pick up negatives if I go in the negative or past pi over 2. Okay, I have to just go past pi over 2 here. So we'd have to have, let's see, let's get this out of here. I have to have this, anything, I did a 3 pi over 4 and I ended up with that negative number. Okay, so then we start to pick up, see, even though you're heading out this way, the points are showing up over here because they're negatives. So even though the theta's over here, your points are way over here. So, and I didn't also notice, I jumped to 3 pi over 4. We could have stopped at another intermediate angle in here, like maybe 2 pi over 3. Okay, we could have done that, 2 pi over 3. It's still going to be some negative number. Let's try this. Let's go ahead and put that in the calculator, 2 pi over 3, just for the fun of it. Two pi divided by the 3. Okay, negative 24. Okay. Remember, pi over 3 was 24, and this one's negative 24. So it kind of mirrors what we're doing here. The farther we get away from the pi over 2, we're just picking up a mirror image of what we saw here. Okay, so funny thing about it is it's coming in, and if you trace the graph of it, it's coming in way out over here. In other words, here's the 2 pi over 3, and your number's way down here. And it's like, the further you get away from that, the closer it gets back down to over here. So it's like heads up this way, and then just comes back out of infinity back around this way. So it's kind of like coming around out to infinity where you can't see it, and then coming back this way. Let's look at the calculator on that one. Okay, I just wanted to put a couple things in here. I got the grapher out here, and I put in a 12 over cosine theta, and that's what I got with my window now. With my window set at a little bit bigger than pi over 2 up to pi, I got those negative values. If you include pi over 2, then the calculator seems to put in all the positives with it. I mean, you kind of, again, you gotta be careful with this, but watch what happens if I just put in pi divided by 2, that this is what it does. Okay, so it kept all going to infinity. But if I want to get the positive side, I got to be in the first quadrant. Got to be before pi over 2. So we'll, if I just make that 0, and we'll get the entire picture. Okay, we could slow that down a little bit. I graphed pretty quickly. You'd have to make smaller steps here. In other words, if I just put an extra 0 in here, I could slow this down and maybe take a look at the way it's graphing. So you can see that starts off and going in the positive direction, and then, wow, that was really quick the way it finished that up. But it did start from down here, it looked like, down at negative infinity, and finished it off going upward. So that was kind of neat to see that.